So how do we add vectors when they are in the same direction? Consider a vector AB having magnitude 3 units and pointing towards right. This is vector AB, its magnitude is 3 units. And we have another vector, vector PQ, having magnitude 5 units and pointing towards the same direction, right direction. Okay, so this shows PQ and its magnitude is 5 units. Both the vectors are pointing in the same direction. So what if we want to add this vector? How do we add these vectors? We simply add them because they are pointing in the same direction. So we simply add the vectors. Okay, so we get another vector on addition. It's xy and its magnitude is 8 units. This is the resultant vector. And it has the magnitude equal to the sum of the magnitudes of the two vectors and direction is same as that of two vectors. So if the vectors are pointing in the same direction and they are of different magnitude and they're pointing in the same direction, they are parallel or they are aligned, then we simply add their magnitudes and the resultant vector has the same direction as that of individual vectors. The magnitude of the resultant vector is given as the algebraic sum of the two vectors. Direction of the resultant vector is same as the given vector. Okay. So addition of vectors when they are in opposite direction. So for two vectors which are pointing in opposite direction. Let's consider a vector having magnitude 3 units, it is pointing towards left. And we have one more vector, vector PQ, it has magnitudes 5 units and it is pointing towards right. Then when we subtract these two vectors, then we get resultant as a vector with a magnitude equal to the subtraction of the magnitudes of individual vectors. Okay, the magnitude of the resultant vector is given as the algebraic subtraction of the two vectors. Direction of the resultant vector is same as the bigger vector. So out of PQ and AB, which one is bigger? Yes, PQ's magnitude is greater than AB. So PQ is bigger. So direction of the resultant vector would be the direction of PQ. It will also point towards the right direction. So it has a smaller magnitude because 5 minus 3 gives 2 units. So you can see length of the arrow is that we have drawn here is smaller and it is towards right. So drawing a law of vector addition is the first method. When two vectors of the same type are represented in magnitude and direction by two sides of a triangle taken in a certain order, clockwise or anti-clockwise, then their resultant vector is represented in magnitude and direction by the third side of the triangle taken in opposite order or opposite direction. Okay. So we have this one vector. This is a first vector. This is a second vector. Then the resultant vector. See, you can see in these two vectors, first thing is that these two vectors are not parallel, neither parallel nor anti-parallel. Neither they are forming 0 degree nor they are forming 180 degree angle. So we cannot add or subtract the magnitudes. These two vectors are pointing in different direction. You can see this red vector is pointing in this direction. This is the direction of red vector and this is the direction of blue vector. They are pointing in different directions. This is point 1 to be noted. Second point to be noted is ending point of first vector is the starting point of second vector. Tail of the second vector coincides with the arrowhead of the first vector. So we call these vectors as they are in the same order. They are in the same order. Vectors are in the same order. If the vectors are pointing in different directions, if the vectors are in the same order में कब होते हैं कि जब एक end हुआ और दूसरा start हो गया वहीं से, ठीक है? Then we apply triangle law of vector addition. What do we do in this law? We focus on the starting point of first vector and the ending point of second vector. Arrowhead of second vector and starting point of first vector, we join these two. points. Okay. And this shows the resultant vector. This third vector is the resultant vector of the given vectors. A vector, first vector and second vector. Okay. Fine. And one more thing, third point to be noted. This vector is not in the same order. You can see first vector and second vector, they are in the same order. And the resultant vector is in the opposite order. Yes. Resultant vector is in the opposite order. Resultant vector जो है वो सेम ऑर्डर में कब होता? आपका जो ग्रीन वेक्टर है ये सेम ऑर्डर में कब होता? ये सेम ऑर्डर में तब होता जब ये स्टार्ट सेकंड वेक्टर के एरो हेड से होता और ये एंड फर्स्ट वेक्टर के स्टार्टिंग पॉइंट से होता, तब ये सेम ऑर्डर में होता। लेकिन अभी ये क्या अपोजिट ऑर्डर में है। ठीक है, तो कौन कौन से 3 पॉइंट्स हमें समझ आए हैं? एक तो एंटी पैरेलल पैरेलल वाला नहीं केस है ये, एंगल पे अगर होते तो हम ट्रायंगल लॉ अप्लाई करते हैं। सेकंड, 2 वेक्टर्स आर इन द सेम ऑर्डर, है ना, एक के एरो हेड से दूसरे का स्टार्टिंग पॉइंट और एक का एंडिंग पॉइंट मीट कर रहा है, तो दे आर इन द सेम ऑर्डर। थर्ड, रिजल्टेंट वेक्टर अपोजिट ऑर्डर। ठीक है, so let's consider an example. Let's consider 2 vectors P and vector Q. Now we have to add these 2 vectors. How will we add these 2 vectors? First we'll place these vectors, हाँ ज्वाइन करेंगे। कैसे प्लेस करेंगे? As 2 sides of triangle, है ना। We can move this vector Q to the arrowhead of P. Let's add the vectors by triangle law and take these 2 vectors as sides of triangle in a certain order. So we can redraw these 2 vectors like this. So you can see starting point of second vector Q is at the ending point of first vector P. Okay, now we can draw the resultant vector, and resultant vector is represented by the third side of the triangle. And the resultant vector starts from the starting point of first vector and it ends at ending point of second vector. So we draw a resultant vector like this. Clear? So how do we write this resultant? It's vector P plus vector Q. How do we draw resultant vector? We start from this first vector and end at the arrowhead of second vector. This is how we draw resultant vector. Now label it. So this is a vector A. This is the vector B. And this is the resultant vector. Okay. And we write resultant vector as vector R is equal to vector A plus vector B. This is how we write resultant vector. Now we are going to find magnitude and direction of this resultant vector. Okay. What are we going to do? We are going to find magnitude and direction of the resultant vector. Okay. Let's write the subheading first. Let's first find the magnitude of the resultant vector, then we'll find the direction. Okay. Let's start from the magnitude. For magnitude of resultant vector. For this, let's consider this angle between this resultant vector and vector A as alpha. And this resultant vector makes an angle beta with vector B. See, R is the resultant vector and A and B are the given vectors. So this resultant vector makes an angle alpha with vector A and it makes an angle beta with vector B. And angle between vector A and vector B is theta. Extend this. This is the angle between vector A and vector B is theta. So what is alpha? Alpha is the angle between resultant vector and vector A. And what is beta? It is the angle between resultant vector and vector B. And theta is the angle between the given vectors, vector A and vector B. Any doubt in this? We'll do a construction here. Draw a perpendicular. Draw a perpendicular. Let this be point O, this point be P, and this is Q, and this is N. Okay. Now you can see that this triangle is a right angle triangle. Triangle QON. Triangle QON is a right angle triangle, right angled at A, right angled at N. So we can apply Pythagoras theorem here. And it says that hypotenuse square of hypotenuse is equal to square of perpendicular plus base square. So what is hypotenuse here? It's OQ. So OQ square is equal to QN square plus ON square. Any doubt? ON can be written as OP plus PN. We can write this ON as OP plus PN. So this can be further written as QN square, and this ON can be written as OP plus PN whole square. Now apply the identity here, A plus B square. Okay, so this implies OQ square is equal to QN square. A plus B square is A square, OP square plus B square, PN square plus 2AB, 2OP into PN. Clear? So OQ is nothing but R. We are only considering the magnitudes. We are not considering the vectors form, not the directions. Only magnitude. Okay. So OQ is R. We can write R for OQ. It's R square. And QN is see, look at this. This is vector B, right? And this QPN is another right angle triangle. In this right angle triangle, we can apply, we can write QN, this is perpendicular trigonometric ratios. No? QN upon PQ. Perpendicular by hypotenuse is sine theta. So QN can be written as PQ sine theta. And what is PQ? PQ is B. And similarly, we can write for cos theta. For base upon hypotenuse. Base is PN. Hypotenuse is PQ. So PN upon PQ is equal to cos theta. So we can write PN as PQ cos theta. PQ is B. So it's B cos theta. So now we got this. QN is B sin theta and PN is B cos theta. So in place of QN, we can write B sin theta. And where we have PN, we can write B cos theta there. No? So let's write for QN, we are going to write B sin theta. So it's B sin theta whole square. And OP is A square. No? OP is vector A, right? And PN is B cos theta. PN is B cos theta. So it's B cos theta whole square plus 2OP. OP is A into PN is B cos theta. Clear? Now we can write A square. And here we have B square sin square theta and B square cos square theta. We have two different terms. So we'll take B square common. In the bracket, we can write sin square theta plus cos square theta plus 2AB cos theta. This sin square theta plus cos square theta is 1. Yes, it is 1. So this therefore R square is equal to A square plus B square plus 2AB cos theta, or we can write R as square root of A square plus B square plus 2AB cos theta. This is the magnitude of the resultant vector R. And close this in box. We'll be using this formula, ठीक है, in different numerical problems. ये बहुत ज़्यादा use होने वाला है अभी आगे. So learn कर लो, समझ लो, understand कर लो, fix कर लो, scan कर लो. ठीक है. Okay, now we have to find direction of R. We have found out the magnitude. Now let's find the direction. Any doubt in this? Whatever we had done, any doubt in that motion? Clear है सब कुछ सबको? Great. Now let's find direction. Direction of vector R. How can we find direction? For direction, we need to consider the angle. In which direction it is, मतलब in कितने angle पे है वो? किस direction में means कितने angle पे, right? So let's write in terms of alpha first. So tan alpha. We can write tan alpha as, because tan theta is perpendicular by base. So let's consider this triangle OQN. In this triangle, what is perpendicular? It is QN. And base is ON. QN and ON can be written as OP plus PN. What is QN? It's B sine theta. And this OP is A. PN is B cos theta. A plus B sine theta upon A plus B cos theta. Let's write this again. Tan alpha is equal to B sine theta upon A plus B cos theta. And close this in box. Done. Now, let's draw another perpendicular. Starting from P and it goes to this side. OQ. Let this perpendicular be OPM. Okay. So draw PM perpendicular on. Now consider, see, if I, if I write this in the same form that as we have written for QN and PN, P sine theta, B cos theta, we can also write for PM. Look at this triangle. This OMP. This triangle. In this triangle, this angle is alpha. This is vector A. Vector A is like hypotenuse, no? It's hypotenuse. And this is the base with 90 degree, and the angle is the base, right? If you have two angles, one is 90 and other is some other angle, then that is the base. And this we consider as perpendicular, this we consider as hypotenuse, this side, right? So this is the base. OM is the base because we have 90 degree and this angle here. This is base, this is hypotenuse, and this is perpendicular. So we can write PM in terms of A and alpha. क्या लिखेंगे? PM is equal to PM upon OP is equal to sine alpha, no? It's perpendicular upon hypotenuse. So PM is OP sine alpha. OP is A. So we can write A sine alpha for this. No? ठीक है ना? लिख सकते हैं ना? A sine alpha. Similarly, consider another triangle. This triangle PQM. Here this is 90 degree, and this is beta, this is base, and this is perpendicular again. So PM, this time hypotenuse is PQ. No, hypotenuse is PQ, right? So PM is the perpendicular and PQ is the hypotenuse, and perpendicular upon hypotenuse is sine beta this time because the angle is beta. So we can write PM as PQ sine beta. PQ is B, so it is B sine beta. Clear? Any doubt? Any doubt here? Great. So consider triangle OQN. QN is equal to B sine theta, and B sine theta is equal to R sine alpha. ये कैसे आया? कैसे आया? B sine theta, if we consider the smaller one, then it is B sine theta. If we consider QPN, then it is B sine theta. For QPN, the side is B sine theta. But if we consider the bigger triangle, QON, look at this triangle. I'm just going to redraw this for you. This is vector R, this is alpha, this point is O, this is Q, and this is N, no? So we can write this is as perpendicular, this is R sine alpha, perpendicular is R sine alpha, and base is R cos alpha. We can write like this. आ गया है? तभी बहुत आराम से करवा रही हूँ, जल्दी से, धीरे धीरे, डोंट वरी. ठीक है, जहां पे समझ नहीं आएगा वहां पे हम दोबारा कर सकते हैं. इधर बनाऊंगी आपको आपको. ठीक है. So यहाँ से if you consider QPN, then it is B sine theta. But if you consider the bigger one, then it is R sine alpha. So R sine alpha and B sine theta, they are equal. Okay. So we can write R, see, just transpose them. Move sine theta to this side and this sine alpha to other side. So we can write R upon sine theta is equal to B upon sine alpha. Theta is the angle between vector A and vector B. Alpha is the angle between vector R and vector A. R sine theta upon B sine alpha. Let this be 1. Now consider another triangle, triangle OPM. OPM. OPM is here. This triangle. Okay, here we have PM is equal to A sine alpha. Yes. And in triangle PQM, PM is equal to PQM is this triangle. PQM is equal to this triangle. PM is equal to B sine beta. Therefore, we can equate these two. A sine alpha is equal to B sine beta. Again, move these signs here, transpose them. So you'll get A upon sine beta is equal to B upon sine alpha. You'll get this. Mark this as 2. Mark this as 2. Now look at these two, equation 1 and equation 2. What do you get from these two equations? We have one term common, and that term is Tell me. B upon sine alpha. Here we have B upon sine alpha, and here also we have B upon sine alpha. So we can write them together because A is equal to B, B is equal to C. This implies A is equal to C, and A or A, B, C all are equal. This is what we do. So we can write them together. First, write the first equation that we have formed. R upon sine theta is equal to B upon sine alpha. Now this B upon sine alpha is also equal to A upon sine theta. Write them together like this. And close this in. ओके अब याद कैसे रखना है, इसको मेमोराइज कैसे रखना है, ये तो हम भूल जाएंगे ना, भूल सकते हैं, नो भूल सकते हैं राइट। देखो बहुत इजी वे है, इसमें कोई प्रॉब्लम नहीं आएगा, इसमें कोई प्रॉब्लम नहीं आएगा, यहाँ कंफ्यूजन क्रिएट हो सकता है। आर के नीचे जो साइन थीटा है वो एंगल है बिटवीन ए एंड बी वाला। आर के नीचे जो एंगल हम कंसिडर कर रहे हैं वो एंगल कंसिडर कर रहे हैं जो आर नहीं का नहीं है, जो आर से बिलोंग नहीं करता, जो तो दूसरे वेक्टर से बिलोंग करता है। सिमिलरली B के नीचे we are writing the angle which does not belong to B, it belongs to A and R. A के नीचे जो हम एंगल लिख रहे हैं, the angle that we have written here is beta, and this beta does not belong to A, it belongs to B and R, है ना, ऐसे याद रहेगा ना। तो नीचे जो एंगल के साथ कौन सा वेक्टर लिखना है उसमें कंफ्यूजन नहीं होना चाहिए, तो आपको बी के साथ नीचे कौन सा एंगल लिखना है जो ए और आर से बिलोंग करता है, जो ए और आर के बीच में है। ए के नीचे जो एंगल लिखना है वो बी और आर के बीच में है, आर के नीचे जो एंगल लिखना है वो ए और बी के बीच में, जो उससे बिलोंग नहीं करता, थर्ड वाला है, मतलब अदर टू वेक्टर्स है, एंगल बिटवीन अदर टू वेक्टर्स है, ठीक है। So this is how you can memorize it, learn it, उससे मिस्टेक्स के चांसेस आपके रिड्यूस हो जाएंगे। Case 1. Case 1 is, what if two vectors are pointing in the same direction? Two vectors are in the same direction. If two vectors are pointing in the same direction, vector A is here, vector B is also here. We can draw vectors like this. Then the value of angle theta. What is angle theta here? See, we have, when we draw vectors like this, then this is angle theta, no? If this is vector A and this is vector B, then angle theta is the angle between these two vectors. And we draw a resultant vector like this. And angle between these two vectors is alpha and these two vectors is beta, right? So value of theta is, if two vectors are pointing in the same direction, then theta is equal to 0 degree. They are in the same direction. If they are in the opposite direction, then angle is 180 degree. Theta is equal to 0 degree. And alpha, what is the value of alpha? If they are pointing in the same direction, then alpha is also 0 degree. And beta, beta is 0 degree. So theta is equal to 0 degree. Let's find vector r first. R is square root of a square plus b square. 2ab cos 0 degree we can write. Cos 0 degree is 1. So it's a square plus b square plus 2ab. So we can write a plus b whole square. Another way. A plus b whole square, it's a plus b. This is the resultant vector. And tan alpha is b sine theta upon a plus b cos theta. So b sine 0 degree upon a plus b cos 0 degree. Sin 0 degree is 0, cos 0 degree is 1. So it's a plus b, we get 0. Tan alpha is 0 at 0 degree. So this implies alpha is equal to 0 degree. And what if the vectors are pointing in the opposite direction? Two vectors are in the opposite direction, then theta is equal to 180 degree. Vector A is pointing in this direction and vector B is pointing in the opposite direction. Then angle theta is 180 degrees. So we can find angle R. R. It's square root of A square plus B square plus 2AB cos 180 degree. Value of cos 180 degree is, we can write, yes, it's -1. Cos 180 degree can be written as cos 180 degree minus 0 degree. It is minus cos 0 degree. Minus cos 0 degree is -1. It's -1. So we can rewrite this as A square plus B square minus 2AB. This is square root of A minus B whole square, or it is A minus B. Similarly, we can find tan alpha. It's B sine 180 degree upon A plus B cos 180 degree. Sine 180 minus 0 is sine 0 degree is 0. And niche we'll have A minus B, result is 0. This implies alpha is equal to 0 degree. Done? Should I clear this? First case. First case को clear कर देना. Third case. When two vectors act at right angles to each other. What is the angle? Theta is 90 degree. Two vectors are acting at right angles to each other. Vector A is like this. Vector B is pointing in this direction, and this is the angle between these two. It is 90 degree. They're perpendicular. So we can write R as square root of A square plus B square plus 2AB cos 90 degree. Cos 90 degree is 0. So we'll get square root of A square plus B square. And tan alpha can be written as, it is B sine theta. For theta, we'll write 90 degree upon A plus B cos theta. Again, theta is 90 degree. Sine 90 degree is 1. And cos 90 degree is 0. This is B by A. B upon A. Okay, so these are the three special cases. Okay, now tell me the questions of answers of few questions. When is the resultant maximum? When is the resultant maximum? Yes, when theta is 0 degree, when they are pointing in the same direction, then resultant is maximum. R max is when we have theta 0 degree. And when is the resultant minimum? Yes, when the vectors are pointing in different direction, then resultant is minimum and theta is 180 degree. two forces. We have two forces F1 and F2. Okay, and the ratio of their magnitudes is given. Its ratio is 3:5. Resultant of these two vectors, let's denote resultant by Fr, R for resultant, F for force. Okay, so resultant force is 28 Newton. If the angle of their inclination is 60 degree, angle of the inclination means angle between F1 and F2 is 60 degree, find the magnitude of each force. So we have to find the magnitude of F1 and F2. This is the question. Try this one. So this is vector, you can say F1. This is vector F2. Angle between these two vectors is 60 degree. This is 60 degree. And let this be the resultant vector. Vector R. And vector FR, na? We have written vector FR for this. Let's write FR. This is equal to 28 Newton. So, ratios are given. कैसे करेंगे? बोलो. Let vector F1, magnitude of F1 be 3x, because ratio is given, 3:5, and F2 be 5x. Yes. How do we write resultant vector? As square root of F1 square plus F2 square plus 2 F1 F2 cos theta. Now put the values here. It's 28 is equal to square root of F1 square is 3x whole square. F2 square is 5x whole square plus 2. F1 is 3x. F2 is 5x cos 60 degree. 28 is equal to 9x square, 25x square, 2 3s are 6 5s are 30, x square cos 60 degree is 1/2 and this implies 28 is equal to, Hanji batao, 49x square. We can write this as 7x. 28 by 7, its value is 4. F1 is 3x, 3 into 4 is 12 Newton. And F2 is 5x, it's 5 into 4, 20 Newton. So these are the two forces. How do we find greatest resultant? What is the meaning of this term, greatest resultant? Maximum? Maximum? So if we consider vectors of forces as, we have two forces. If we consider forces as, you can consider F1, F2, or you can take A and B, it's your choice. These are just vectors that we are considering, right? So let's consider the vectors as A and B. The forces as A and B. Okay. So greatest means A plus B. A plus B is 25. I will simply add them. You'll get 2A is 30. So A is 15. So on solving, we get A as 15. And value of B, 15 Newton, and B is A is 15 Newton and B is 10 Newton. Yes. Now, when each force is increased by 5 Newton, write this statement down. When each force is increased by 5 Newton. Then the new forces are we can write A1 and B1. So A1 was 15. Na? A was 15. So A1 is 15 Newton plus 5 Newton. We can write it's 20 Newton. And for B1, it's 10 Newton plus 5 Newton. It's 15 Newton. Okay. Find the resultant of two new forces acting at right angles to each other. We have to find the resultant. They are acting at right angles to each other. What is the angle between them? It's 90 degree. So find the resultant now. Resultant is square root of A1 square plus B1 square plus 2A1 B1 cos theta. Now put the values. A1 square is 20 square. B1 square is 15 square plus 2A1 is 20. B1 is 15. Cos theta is cos 90 degree. Okay, cos 90 degree is 0. ये vanish हो जाएगा यहाँ से 0. 20 square is 400 plus 225. So it's 625. Square root of 625 is 25. So resultant is 25 Newton. ठीक है.